The total cost to produce Q items is given by this total cost function. C of Q equals 19,000 plus 19.3 Q. And we first determine the total cost in producing 700 items. So therefore, we plug in Q equals 700 into the total cost function. So we get C of 700, and this equals 19,000 plus 19.30 times 700, and so this gives 19,000 plus 19.3 times 700 equals 12,510, and so when we add these two we get 32,510, and this is in dollars. So this is the total cost in producing 700 items. We also determine the marginal cost when producing 700 items. So first, we write down the marginal cost by finding the derivative of the cost function. So let's find the derivative of the cost function, which I write down as C prime of Q. And this equals the derivative of 19,000 is a constant is 0. And the derivative of 19.30 Q is basically 19.3, and derivative of q is 1. So it is 19.3. And so we can now say that the marginal cost to produce 700 items is going to be 19.30 because it is independent of q. So even if we plug in q equals 700, this c prime of 700 is going to be 19.30, and this is in dollars. So this is the marginal cost when producing 700 items. We now determine the total cost of producing 300 items for this total cost function. C of Q equals 32,000 plus 13.30 Q minus 0.003 Q squared. So we plug in Q equal to 300 into this total cost function, which gives the total cost of producing 300 items. And so this equals 32,000 plus 13.30 times q. Replace q by 300 minus 0.003. Replace 3 q by 300. It becomes 320 squared. And so when we simplify this numerical expression using a calculator, we get 35,720, and this is in dollars. And so therefore the total cost of producing 300 items is $35,720. Now let's determine the marginal cost when producing 300 items. So for that we should find the derivative of the total cost function. Let's find the derivative, which we write down as c prime of q. And so this equals the derivative of 32,000 is a constant is 0, and the derivative of 13.30 q is 13.30 times the derivative of q is 1 minus the derivative of 0.003 q squared is 0.003, and then derivative of q squared using the power rule is 2q. So let's simplify this. So we get c prime of q, This equals 13.30 minus 0.003 times 2 is 0.006. So this is 0.006 Q. Now we find the marginal cost when producing 300 items. So plug in Q equal to 300 into the marginal cost function. We get C prime of 300, and this equals 13.30 minus 0.006 times replace Q by 300, and so this equals 13.30 minus 0.006 times 300 equals 1.8. So I write 1.8. 13.30 minus 1.8 equals 11.5. So this is 11.5, and this is in dollars. And so this is the marginal cost when producing 300 items. We now determine the increasing and decreasing intervals from the graph of the function. So we can see that the function is increasing starting from this point. It increases till it reaches this point. So it looks like this point is x equal negative 1.5. So we can see that starting from negative 1.5 to this one is between 1 and 2, that is a positive 1.5. So this is the increasing interval, and it is decreasing apart from this interval. That is, you can say that from negative infinity till it reaches x equal to negative 1.5, it decreases, and after x equal to 1.5, the function is decreasing. So therefore, we say that the decreasing intervals are from negative infinity to negative 1.5 union 1.5 to positive infinity. So we have determined the increasing and decreasing intervals.